Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good afternoon, guys. Okay, so this is week number 6. Okay, week number 6. And we are going to cover something that is going to be quite interesting. Okay, let me see why I cannot handle this. Okay. Okay, we are going to have this processing talk show. Okay, we are going to study the chemicals that are actually produced from methane, right? Primarily, indirectly, secondary, so on. Okay. By the way, I just want to see whether you guys are here with me. So if you are here with me, just put thumb ups, please. And as usual, if you see I'm looking at that side, it's because I have my other laptop this side. But let me just put it. Okay, so maybe it won't interrupt that much. Okay, good. So you guys are here. Alhamdulillah. All right. So now I just want to say that there are plenty of chemicals that can be actually derived from methane. Okay, so we have learned from our first week that the main feed to produce a lot of petrochemical feedstock comes from petroleum itself and also natural gas. Okay, but then we are now focusing on methane. Okay, methane is one of the products that can be produced from natural gas, mainly from natural gas, not really from petroleum. Okay, but then we also can get methane from petroleum depending on what technology we are using and also what kind of feed. All right. So there are certain situations, okay, that we can also get methane from petroleum feedstock. Okay, but today, okay, so now I'm acting as sometimes as a lecturer and sometimes as your host for this program, this talk show program. And I hope you guys are okay and not nervous, okay? All right, so we are going to begin, okay, with looking at this slide. Okay, I believe you all have looked at this slide from the notes that I have given. Okay, we have methane that can actually produce 5 products if we refer to the diagram. Okay, we have hydrogen cyanide, carbon disulfide, syngas, chlorinated methane, single cell protein, and so on. And then from that, we can produce from the synthesis gas, we can produce several other compounds that include hydrogen, ethylene glycol, Fischer-Tropsch hydrocarbons, oxo alcohols, and also methanol. And from the hydrogen, we can combine, we can mix it with nitrogen to produce ammonia and so on. So you all already understand this, okay? But from time to time, I'm going to show this screen so that we know where we are when we are discussing and when we are going through the talk show. All right. So team number 1. Team number 1, are you ready? Team number 1 consists of, I remember there's, okay, I cannot remember. All right, so team number 1, if you're ready, can you please switch on your camera? Okay. So good morning, guys. Good afternoon, guys. Okay, this is team number 1. Okay, team number 1 consists of Engineer Aaron, anak lelaki Anthony from Rasgas, okay, and Dr. Farah Hanis binti Aziz from Petron. Really, Farah? And then Datuk Muhammad Akil bin Muhammad Fariza from Prefcam. So this is Nuri Akil. Welcome to the show. Okay. So this here we are going to listen from our expert panels about how methane is obtained from oil and gas. Okay, so a lot of us think that we can easily obtain methane from oil and gas, but how? So that is actually the interesting question, and I believe our audiences here are very interested, and a lot of them are in the area of chemical engineering, chemistry, and so on. So they are dying to know how we can get methane from oil and gas. So Engineer Aaron, Dr. Farah, Dr. Akil, are you ready?
Yes, we're ready.
All right, cool.
Yes.
Okay, so I have the way we are going to conduct this is I have some questions. I'm going to point out the question to the panel. Okay, so the panel depending on maybe who I feel is suitable to answer the question. All right. Okay, so let's see. Okay, let me just give start the show. Okay. So the first question: how methane is actually obtained from offshore? Okay, how methane is actually obtained from offshore? Okay, I'm going to deliver this question to Dato Muhammad Akil. Okay, can you please enlighten us how we can actually obtain methane from offshore?
Yes, for methane from offshore is usually the natural gas is located in the ground of the seabed. I mean, it's very deep in the earth crust, and then uh, the natural gas is obtained by drilling, and then it is transported to the refinery plant so that from that through a distillation column, fractional distillation to get the light components of which consists of methane.
Is that all, Dato?
Yeah, that's all for me.
Okay. Thank you very much, Dato. Maybe Dr. Farah Hadis, maybe you want to add something due to your expertise in while doing your PhD before?
For me, methane can obtain from natural gas by drilling the well from the ground, and then the natural gas obtained is transferred through the pipeline.
And then, are you done, Farah? Dr. Farah?
Hello, doctor.
Yes. Can you hear me?
Can.
Okay.
Then, okay, from the pipeline, the natural gas can transport from the pipeline and to the distribution networks, which is to the maybe a refinery, company or factory.
Okay.
That's all.
That's all. Okay. Thank you very much. So, from the response from Dato and also from Dr. Farah, okay, they mentioned that okay, we can get it from offshore because there's a reserve of natural gas, okay, inside the seabed, and then it will be actually drilled, okay, not drill, drilling will happen, okay, drilling will take place, and then it will be actually captured and stored inside this what we call FPSO, which is floating production, shipping and offloading, or we call it FPSO. Okay, FPSO is a very huge, massive tank at the sea, okay, nearby the offshore platform, which is required to filter, to process the raw natural gas, and then it will be actually delivered or sent to the land. In Malaysia context, okay, in Malaysia context, from the South China Sea, the gas will actually be sent to GPP, GPP1, GPP2, 3, 4, 5, 6. GPP stands for gas processing plant. It's just the same like what you receive inside your assignment, your project assignment, not plan design project, but then the project assignment that I gave you, the moderator gave you, okay? Okay, so those when you have that gas processing plant, it will actually process, and then it will actually filter or separate the methane from ethane or from other compounds. Okay, All right, maybe let's go to Engineer Aaron. Okay, Engineer Aaron, are you there?
Yes,
All right. Yes. Okay. Uh, okay. Here's an interesting thing is that a lot of people they are not sure how much natural gas composition are there. Sorry. How much methane is actually composed inside natural gas? So my question to you is, how or what are the percentage of methane inside natural gas? So that's the first question. And then the second question, where will be the natural gas be processed? Tips, I just gave you the answer just now.
Okay. Thank you, Doctor, for the question. To answer the first question, how much percentage of methane is, consists in the natural gas? From my understanding and from my research online, I found out that natural gas is mainly composed of methane, which is about 85 to 90%. And then it is also made up of other substances like water, um, water, propane, butane, carbon dioxide, oxygen, and so on. So, and this is the raw natural gas. So the raw natural gas will be transported to the refinery, to the gas processing plant through the pipeline. And then,
Okay. And then?
In the gas processing plant, they will process the raw natural gas. So they will remove all the impurity and make the natural gas to consist only methane as much as possible. So first they will remove all the acid gas, then they'll remove other substances like condensate and water, and also its mercury and nitrogen and so on. So after a series of processes, they will obtain the purified natural gas, which mainly consists of methane. Yeah, that's all from me, Doctor.
Okay. Thank you very much, Engineer Aaron. So that's correct. Yeah, I also heard about that. So I can affirm that what you are answering is true. Okay. Thank you very much, Engineer Aaron. Okay, I'm going to give the next question. And this question is dedicated to Dr. Farah. Okay, Dr. Farah, can you give me and the audiences 3 uses of methane gas? Can you hear me?
So, Doctor,
Yes.
can you repeat again your question?
Okay. Can you please give us 3 uses of methane gas? 3 uses
Uses
of
of
methane.
So the uses of methane gas usually we can use as transportation,
Okay.
fuel transportation, and then if I'm not mistaken, methane also can use for heat, the source of heat to produce heat for heating purpose.
Okay. Others? So that's 2. The third one?
The third one, uh,
Perhaps you can also use it for certain chemical reaction to produce something else.
maybe it can react with a chemical that will produce a fertilizer. It can also can react with others chemical to produce a fertilizer.
Okay. All right. It may not be able to directly produce the fertilizer, but then indirectly after several stages, it can produce fertilizer. All right, thank you very much, Dr. Farah. Dato' Akil, are you there?
Yes, I'm here.
Okay, Dato'. Um, which country actually produces or releases the most methane?
So thank you for the question. From based on my experience, the most methane that is produced by China.
Oh,
Yeah, and but Malaysia also got methane, which at located at most of the refinery plants such as Malacca Refinery Complex, Refinery and Petrochemical Refinery. Yeah, but the most produced methane is from China.
okay. All right. Thank you very much, Dato'. Dato', are you okay? You don't feel quite well. You are not usually like this. Are you okay?
Yeah, this is my first time on talk show, so I have a little bit nervous, but I think I'm better now.
Okay, okay, cool. Okay, that's good. Okay. So relax, okay? This is just for fun talk show, okay? Okay, Engineer Aaron, are you there? Yeah, you are there, right? Okay, Engineer Aaron, what are the advantages of using natural gas instead of fossil fuels?
Okay, thank you, Doctor, for the question. There are few advantages of using natural gas instead of other fossil fuel like coal and crude oil. One of the advantages is that natural gas, which consists mainly of methane, is able to produce more heat and light energy by mass than other hydrocarbons. Okay, and other than that, it also produces significantly less carbon dioxide and other pollutants that contribute to smoke and unhealthy air. So, by using natural gas, the uh, the contribution of natural gas to air pollution is lesser when we compare it with other fossil fuel like coal or crude oil. Yeah, that's all from me, Doctor.
Oh, so meaning if we use natural gas, it will produce less pollution. Is that what you're saying?
Yes, Doctor.
How about price-wise? The
Uh,
cost?
mm, I'm not really sure on that, but I think natural gas is uh, almost when we use natural gas instead of other fossil fuel, I think the price is not very, it's not so different, and but I need to check on that because I'm not really sure on the price.
Okay, okay, no problem. Engineer Aaron, can you please take note on that? And then after our class, sorry, after our talk show, maybe you can put that inside e-learning, okay? The price comparison between fossil fuel and also natural gas. Is that okay?
Okay, Doctor, sure.
Sure, okay. All right. Because the three of you are the first group of panels, expert panels. So I'm going to give less question to you guys, okay? Because you set the benchmark and the others are watching you. So I'm not going to ask more questions, but I'm going to open the session to the three of you. Anything else that you want to add here? Anything? Maybe you have prepared some illustration or something. If you want to share, feel free to share. If you don't have, it's okay, no problem. Dato', anything?
Yeah, actually, I have one thing to share, but because of this topic is from oil and gas. I
Okay.
prepared from coal actually, and it doesn't suit the topic, but it's okay. Just want to share that methane also can be obtained from coal,
Okay.
from the fossil fuel coal, and this technology extracting methane from coal is commercially produced, commercially used in Australia, because Australia has one of the source of coal in the world.
Oh,
So
all right.
yeah,
That's okay. Yeah.
mm,
Anything else you want to add?
that's all from me.
Okay, since you have added that information, I'm going to ask you more about that.
Yeah,
You mentioned that Australia is one of the producer of coal. How is it compared with China in terms of coal production?
state of corporation. Oh, um, co-production from Australia, I believe it's from the coal seam at the below ground, 1 kilometer below surface. And from China, I'm not really sure about how they obtain the coal.
Okay. Maybe I can add a little bit. Actually, China is the largest producer of coal in the world, or maybe one of the largest coal producer. It also can produce methane from coal, as well as it have the technology of coal conversion to methanol directly from, I repeat, coal conversion to methanol. And not only that, it can also go from coal to olefins. China is doing that at the moment at central China. Okay, so this is just some additional information that maybe I would like to share with the audiences. Okay, thank you, Dato, for your input. How about Dr. Farah and Engineer Aaron? Any last addition of information that you want to give? Dr. Farah, anything?
I think I don't have anything to add.
Okay, okay, nothing. Okay, thank you, Dr. Farah. How about Engineer Aaron? How about you?
No, doctor. That's all from me.
Okay, thank you very much. Okay, thank you very much to Engineer Aaron, Dr. Farah, and also Datuk Muhammad Akil. Okay, okay,
You,
okay. If you are there, audience, please clap your hand. So those are our expert panel. Okay, thank you very much. Okay, to all of you. We hope you will come visit us in future. Okay, so please feel free when you're free. Okay, we can come again to this talk show. Okay, so
Thank you, doctor.
you can leave now. Okay, thank you very much. Okay, so audiences, participants. Okay, we have our second session. Okay, and this session is actually chemical based on methane. Okay, chemical based on methane. And we have three renowned expert panels. Okay, Dr. Aimi Dayana binti Jairan from UMS. Okay, okay. Hi, Dr. Aimi. And professional technologist Gaura Chandrika, anak perempuan Arumugam. Are you there? I hope you are there.
Yes, doctor, I'm here.
Okay, okay, okay. I'm not seeing you inside camera yet. Oh, there you are. Okay, yeah. Okay, how are you, Gaura?
I'm fine.
Okay. Are you excited with the talk show?
Kind of,
Or rather nervous?
I would say more nervous.
Oh my God, this is just our normal class. Okay, okay. How about let's welcome engineer Yojendran, anak lelaki Mari Vanan from Malakoff. Are you there, engineer Yojendran?
Yeah, I'm here.
Okay, all right, there you are. Okay, okay. Oh, you look very handsome today.
Thank you.
Okay. By the way, I forgot to mention that professional technologist Gara is from PRSS, Petronas Research Scientific Services from Bangi. And Dr. Aimi is from UMS, University Malaysia Sarawak. Dr. Aimi, you are from Sarawak, right?
I'm from Sabah, doctor.
Okay, from Sabah. Okay, so Sarawak and Sabah is not that far apart, right? Okay, so it's better rather than working in Peninsular Malaysia for you. Okay, all right. Okay, so we have this topic, and I hope you guys are ready with the question that have been set for you guys. Okay, so a lot of people were wondering what are the chemicals that can be produced from methane, and me myself, I am also wondering what are the chemicals. But we are going to get your opinion from this talk show, okay? So our first question, okay, the first question is directed to Dr. Aimi, okay? Can you please list down or maybe state what are the chemicals that can be produced from methane?
Thank you, doctor, for the question. So there are a few chemicals that can be produced from methane, which is the hydrogen cyanide, carbon disulfide, synthesis gas, chlorinated methane, and also the single cell protein.
Okay, okay. Anything else maybe apart from that?
There are many actually left, but then that's all that I managed to.
All right. You answered that pretty fast, Dr. Aimi. So that's amazing. Okay, next question will be for professional technologist Gaura. So just now, okay, Gaura, okay, just now Dr. Aimi just mentioned about some of the chemicals that can be produced from methane. One of it is hydrogen cyanide. Many people here have heard about hydrogen cyanide, or maybe some of them have heard but not sure what is hydrogen cyanide. Okay, maybe you can enlighten us. Okay, maybe describe what is actually hydrogen cyanide.
So basically hydrogen cyanide is a highly poisonous gas that is very volatile, and it's a liquid with a bitter element odor. Usually hydrogen cyanide is used mainly as a fumigant. So fumigant are volatile substances that vaporize and are usually used to kill insects and yeah, basically that. So also usually used for production of synthetic rubbers, electroplating, and also for mining. That's just the basic introduction of what hydrogen cyanide is.
Oh, okay. How about the chemical structure of hydrogen cyanide?
So hydrogen cyanide has hydrogen, of course, carbon, and also nitrogen atoms.
So
HCN.
HCN, correct? HCN. All right, right. Okay. So it's a combination of hydrogen, carbon, and nitrogen. Still with you, Gaura. Okay. Did you or do you recall? Okay. Do you recall any disaster that is related to hydrogen cyanide in the world?
There is actually in the world.
The one maybe the one in Bhopal. Have you heard about it?
Yes,
Bhopal.
the fertilizer company. I believe so.
Actually, it produces isocyanide. Okay, isocyanide. So it is not hydrogen cyanide, but it's almost like almost as toxic as hydrogen cyanide, and it happened to be the worst disaster in the world in terms of chemical plant accident. Okay, how many people died from there? Anybody among you, the three of you, can answer that? Any guess?
I'm going to say about 2,000, but I think there's more than 20,000 affected by it. It's likely.
Yeah, actually there are a lot more died. Okay, so I think it's more than 10,000. So the incident in Bhopal, it was not actually a physical explosion that we can see, we can feel the impact. It's actually coming from the hydrogen cyanide as a gas. Sorry, hydrogen isocyanide as a gas that was released by multiple failures of control. Okay, so it was released to the atmosphere, and then from the atmosphere, when it was released, it was very unfortunate that the wind was blowing that time, and then the wind helped to spread the isocyanide to the village there at Bhopal. And then people didn't know, but people started to feel drowsy, feel pening-pening, feel not sick, feel sick, okay, and then they feel not okay, they want to vomit, and eventually a lot of them died. Okay, some of them, those mother got their baby bonds mutated, so it's a very sad situation. By the way, there's a movie called Bhopal, A Call for Rain. So if you have not watched that movie, you should watch it. Okay, Bhopal, A Call for Rain. So it's almost like if you recall Deepwater Horizon. Okay, Deepwater Horizon, the accident that happened in the Gulf of Mexico that received Hollywood treatment. Okay, this one also received Hollywood treatment, but not as the marketing was not as Vaganza as Deepwater Horizon. Okay, okay. Anyway, that's different story. Okay, let's talk about hydrogen cyanide again. Okay, maybe I'm going to direct this question to Engineer Yogendran. Am I pronouncing your name right? Yogendran or Yogendran?
It's Yogendran, doctor.
Yogendran. Okay, sorry about that,
No,
Engineer Yogendran. Okay, okay, the question is, how hydrogen cyanide can be produced?
okay. So there are basically a lot of methods that we can utilize in order to produce hydrogen cyanide. So I'm going to discuss three main methods. So the first of all is Enduso process. Secondly is Degussa process, and thirdly is methanol reaction with ammonia and oxygen. So basically, Enduso process is an endothermic reaction in which there is a catalyst used, which is platinum and rhodium catalyst, in which platinum will be used for 90 weight percentage, and for rhodium is 10 weight percentage for the reaction. And the temperature for the reaction is around 1000 degrees Celsius with a pressure of 13 to 16 atmosphere. And the yield expected from this reaction is around 55 to 60%. And secondly, for the Degussa process, it is actually the same process as of Enduso process, but the difference is that in the Degussa process, no oxygen is involved. It's a it's an anaerobic process, in which the Enduso process is the aerobic process. Okay, so for this Degussa process, the catalyst used is platinum, and it will be operated at 1400 degrees. And finally, the hydrogen cyanide can be produced from the relation between ammonia and also ethanol. The process is called the carbon reformation of hydrogen cyanide. Yeah.
Okay, are you done?
Yes.
Oh, okay. So I heard just now, because your voice was not really sharp. Okay, but then can I just repeat? So you are saying that there are several processes to produce hydrogen cyanide. One of it is using the Andrusol technique or approach. Okay, and then the other one is the Degussa process.
Yes.
And I missed the third one.
The process is the reaction between ammonia and oxygen with methanol.
Oxygen.
The process name is amoxidation of methanol. Yeah.
Or amoxidation of
Methanol.
ethanol.
Methanol.
Okay.
Yeah.
All right. So I hope our viewers can hear you clearly also. All right.
Oh,
If
okay.
not, I believe you all have actually prepared some pamphlet in some kind like a one-page note. So I'll actually disseminate your notes to them. Okay, to our audiences. All right. Thank you very much, Engineer Yogendran. So we know that hydrogen cyanide is one of the chemicals that can be produced from methane. Okay, and there are three processes to actually produce hydrogen cyanide: the gusa, androsol, and also the third one I kind of forgot, but then let's refer to the note later on. Okay. Okay, so let's go to the next question. Okay. This question is directed to Dr. Aimi. Okay, Dr. Aimi, are you okay? Dr. Aimi is waiting for the question. Dr. Aimi, where are you now? Are you in Sabah or in Malaysia, or I mean in JB,
I'm at JB right now.
in UTM?
Yes.
Okay, perfect. Okay, so the question for you is, okay, so you can actually produce carbon disulfide, synthesis gas, chlorinated methane, and some other things, right? Among the four of chemicals that you mentioned before, okay, hydrogen cyanide, carbon disulfide, synthesis gas, and also chlorinated methane. Which one is the very most important? I know you will say everything is important, but then which one is the most important that actually people depend on it, and also people want to try to explore many things, or people are depending on it for energy and so on. So in your opinion, okay, what is it?
I would say it is synthesis gas because there are a few research that has already been done to use synthesis gas as the chemical feedstock for the fuel for engine.
Okay, so okay, what is actually synthesis gas?
So synthesis gas is actually a mixture of carbon dioxide and also the hydrogen that is derived from wide range of carbon feedstock, which usually the composition of the synthesis gas is carbon monoxide, hydrogen, methane, carbon dioxide, and the composition is varies based on the raw material and also the process itself.
Okay, I'm sorry, I didn't hear you mentioning the products just now, the chemicals. Can you repeat that again, that part?
The composition usually is 30 to 60% of carbon monoxide, 25 to 30% of hydrogen, 0 to 5% of methane, 5 to 15% of carbon dioxide. And this composition is varies based on the raw material and also process.
Okay, all right. So actually, for the process to produce synthesis gas will actually produce a mixture of CO, hydrogen, CO2. So that's what you're saying, right?
Yes.
Okay, noted. Can you explain what are the methods to produce synthesis gas? The
There are
the available technology.
a few methods usually used is steam reforming of natural gas, methanation, partial oxidation, and also water gas shift reaction.
Okay. Do you want to help us enlighten us about water gas shift reaction? So that's interesting because I heard about water gas shift reaction, but I always forgot about the reaction, the equilibrium reaction.
So the water gas shift reaction is the reaction between the carbon monoxide and also water at high temperature using catalyst of iron if I'm not mistaken, at temperature of 435 to 500 degrees Celsius
To produce?
to produce the synthesis gas.
So meaning, okay, I'm writing this down. So you're saying just now it's a reaction between CO2 and water, is it?
Yes,
And then at about 400 degrees Celsius to produce CO plus hydrogen. Correct?
yes. It is based on what we have already researched before.
Okay, okay. So is this process reversible?
Um, this process, I'm not quite sure about that.
Yeah, it's okay. Actually, it is a reversible process. So it depends on where the equilibrium is shifted. So if it is shifted to the right-hand side, then it can go to the production of synthesis gas. Okay, so this is quite important because it's a very important building. I mean, CO and hydrogen very important. CO is not as important as hydrogen, but then when it combined, so when it can be used for producing many other compounds. Okay, all right. Now back to professional technologies Gaura, who's anticipating question and she's staring at me. I'm so scared now. Okay, Gaura, can you explain, because one of the product is carbon disulfide. Maybe you can explain about it, about carbon disulfide a bit?
Sure. So basically carbon disulfide is, just a minute. Carbon disulfide is colorless and is also a volatile, toxic, flammable liquid. So basically, carbon disulfide is used in the production of rubber, viscose, rayon, and also feedstock for the synthesis of sulfuric acid. I think that is a short introduction, and it has a very foul smell.
Very what? Cool smell?
Foul, smelly smell.
Oh, smell, the smell is not pleasant.
Pleasant.
Okay, so does it smell like hydrogen sulfide?
No. I think it maybe smells more like ammonia. Stinks.
Oh, okay. So hydrogen sulfide smell is very bad, and but at the same time, carbon disulfide also smell bad, but it tends to mimic ammonia. Right? It's pungent smell.
Yeah, pungent smell.
All right, okay. What about the market demand for carbon disulfide at the moment?
The market demand for carbon disulfide. The global market is currently valued at USD 133.5 million in 2016, and it's projected to expand by 2.4% by 2025. And this is due to the growth and demand of cellophane for the packaging industry.
You say growth and demand of what?
Cellophane.
Styrofoam. Cellophane.
Cellophane.
Cellophane. You mean cellophane tape?
Yes.
Oh, so carbon disulfide is used to make that product.
Yeah.
Oh, okay. Okay. Thank you very much. I didn't know about that. Okay, thank you very much, Gaura. So I'm going to move to Engineer Yogendran. Okay, Engineer Yogendran. I'm going to ask you about the chlorinated methane. Maybe can you give us an introduction of what is chlorinated methane?
Okay, so basically chlorinated methane is a chemical produced from the replacement of hydrogen atom in the methane with the chlorine atom. So basically it can be used in order to produce silicon polymers, solvent, refrigerant, and also it can be used as a paint remover as well. Yeah. So that's basically what is chlorinated methane.
Can you repeat again, because it's not sorry, it's not clear.
Okay, can you hear me now?
Yeah.
Okay, so basically chlorinated methane is a chemical that is formed by the replacement of hydrogen atom in methane with the chlorine atom. So basically this chlorinated methane can be used in order to produce silicon polymers and to produce solvents, refrigerant, and also as a paint remover.
Okay.
Yeah.
So it can produce silicon products, polymers, solvents, and etc. etc. Okay. So it's basically, you're saying that it is just basically replacing one of the hydrogen with chlorine, so it can become chlorinated methane, right? Okay. Thank you very much. Okay, I don't have more question for you guys. Okay, but maybe if there's anything that maybe you want to share extra information, so I'm going to open to Dr. Aimi first. Anything, Dr. Aimi?
Thank you, Doctor. So since before this you asked about the chlorinated methane, fun fact about this chlorinated methane is that methane is actually the most difficult alkane to be chlorinated. So the most common process used to produce this chlorinated methane is by thermal chlorination, where the reaction occurs at high temperature but at atmospheric pressure.
How high is the temperature?
It is 350 to 370 degrees Celsius.
Okay. By the way, just to touch on what you mentioned just now, high temperature. Sometimes, this is just from my experience, okay? Sometimes people say high temperature, but then the definition of high temperature may vary from person to person. Maybe for me, okay, when I was doing my master's and PhD before, my experiment, okay, is actually up to 1000 degrees Celsius. So the furnace that I control. So I may say that I am operating at high temperature, and my high temperature is 1000 degrees Celsius. But then when I say I am operating at 1000 degrees Celsius high temperature, some other person who's doing some other kinds of research, they say I'm operating at high temperature. And then maybe I was thinking, oh, maybe high temperature is 1000 degrees Celsius. But then his high temperature is 5000 degrees Celsius. So it's good if we from time to time, okay, when we discuss with things with people, we try to be more specific. Maybe we can say, okay, the temperature is actually 300 degrees Celsius or 800 degrees Celsius and so on. Okay, Dr. Ivy? All right. So this is just my opinion. I'm just sharing. Okay, I'm sorry. I'm just the host for the show. Okay. Thank you for your additional input, Dr. Amy. How about professional technologist Gaura? Anything you want to add? Your mic.
Sorry. Maybe I can add in a little bit on the final product of the methane. Got one left out, the single cell protein. Basically single cell protein is microbes that are produced using non-organism feedstock such as methane. And the production of single cell protein. So there are three inputs that usually will be used, which is methane, nitrogen, and also oxygen. And then in the presence of a bacteria, which is a Metallococcus capsulatus, will convert the methane using the methane and all of the minerals will produce microorganisms such as fungi and so on, microbes, which will be used in the food industry when there is shortage of food in the future. It's a under development process right now.
Okay. Okay, thank you very much for highlighting that single cell protein. Those are one of the many more chemicals that can be produced from methane. Okay. Okay, thank you very much, Gaura. Okay, how about Engineer Yogendran? Anything else you want to add?
Yes, I also have one fun fact regarding hydrogen cyanide. I want to explain about the toxicity of the hydrogen cyanide. So
Okay.
basically, the hydrogen cyanide, if it is exposed, it can interfere with the body's use of oxygen, our human body's use of oxygen, and can cause harm to the brain, heart, blood vessels, and lungs as well. So the exposure, overexposure, can cause fatal as well. So as Dr. mentioned about the Bhopal incident, so something like that. So in a workplace, if you are exposed to hydrogen cyanide, it is recommended that the workplace exposure to the hydrogen cyanide cannot exceed 4.7 parts per million. So that's a small fun fact about the toxicity level of hydrogen cyanide.
So just now you mentioned hydrogen cyanide will actually block the oxygen transfer to the brain, is it?
Yes, sir. It will interfere with the oxygen. So
Okay.
it's very extremely toxic chemical.
And then the minimum ppm is how much?
4.7 ppm.
4.7 ppm.
Yes, sir.
And then anything beyond 4.7, we are going to die.
It will, as I mentioned, it will cause interference to the oxygen flow, and it may cause fatal as well. It is overexposed.
Okay. All right, all right. Thank you very much for the information, Engineer Yogendran. Okay, so for this session number 2, chemical based on methane, I would like to express my deepest gratitude to Dr. Aimi Dayana, Professional Technologist Gaura, and also Engineer Yogendran. Okay, thank you very much. Okay,
Thank you, Doctor.
thank you.
Thank you, Doctor.
Okay, welcome. Oh, it's a pleasure to have all of you here. Okay, let's move on to the next session. Okay, next session, still chemicals based on methane. And now we have, wow, we have 3 expert panels, okay? Associate Professor Dr. Amira Arifah, are you there? Oh,
Yes, doctor.
I didn't know that you are working in UTP. Okay, so this is very interesting. And Datuk Dharmasilan, where are you, Datuk Dharmasilan? And also Engineer Dr. Muhammad Fadli Hakim Bina from Olefin Malaysia. Okay, Datuk Dharma is from Exxon. Yeah, let me see whether you are there or not. Okay, the 2 of you. Okay, you are there. All right. Okay, good to know. Okay, so you are going to discuss about, we are going to discuss about chemical based on methane. Okay, just now we have one set of panels discussing about chemical based on methane, but we believe your background, okay, the 3 of you have different background because you have different kind of exposure. Okay, so I'm going to ask few questions, okay, and hopefully we are going to learn something from here. All right. Okay. It's quite difficult to ask question here now. Okay. The first question we go to Associate Professor Dr. Amira Arifah. Okay, are you ready? You are ready. Okay, thank you very much. Okay, Dr. Amira, can you name what are the chemicals that can be produced from methane? Maybe you can name a lot more than the previous team, if you can.
About that, I haven't researched more about the chemical on base methane, but I know the basic one that is produced by methane, like the previous team presented just now, which is hydrogen cyanide, carbon disulfide, synthesis gas, and also chlorinated methane, and lastly single cell protein.
Okay. Okay, maybe you have some personal experience with one of the chemicals that can be produced from methane. Is there any chemical that maybe you have personal touch or some historical moment with the chemicals?
I may say that maybe it is hydrogen cyanide that I have touched about it before.
You have what? You have touched it?
I mean, I have learned about the hydrogen cyanide before.
Okay, okay. So what about hydrogen cyanide that you have learned? Maybe you can share with the audiences?
So hydrogen cyanide or HCN is a colorless, rapidly acting, highly poisonous gas or liquid that has an odor or bitter element. So it is highly toxic compound, but it is very useful chemical intermediate with high reactivity.
Oh, okay. So what are the uses of hydrogen cyanide?
So for my experience, I learned that hydrogen cyanide, the major uses of hydrogen cyanide is the manufacture of nylons, plastics, and also fumigants that Gaura explained just now.
Oh, okay. So it is also very useful, right?
Yes,
So
that's
a lot of materials that we have, we can see around us also uses hydrogen cyanide. So am I correct?
yes.
Okay, that's interesting. Okay, okay, thank you very much, PM Dr. Amira. Okay, I want to move on to Dato Dharma Shilan. Dato, where are you, Dato? Are you there?
Yes, Doctor.
Oh, I vividly can hear you. Maybe you can put the mic closer if possible. The audiences are dying to hear you explain things. Okay.
Doctor, can
Okay,
you hear me
Dato,
now?
what are the, pardon?
Can you hear me now?
Yes.
Okay.
Yeah, it's better. Okay. Okay, Dato, do we have any hydrogen cyanide plant in Malaysia?
Uh, yes, Doctor. Uh, chemicals.
Yes. Oh, that's interesting. What? BP chemicals?
Yeah, BP chemicals.
In which location or which area?
BP chemicals. I'm not sure about it, but BP chemical produce hydrogen cyanide.
Okay, so maybe you are referring to BP chemicals at Gebeng, Kuantan. So there's a plant that there's a BP chemical plant in Gebeng. So maybe those are the hydrogen cyanide is one of the product from BP chemicals. Okay, how about, do you know any plant in Malaysia that produces carbon sulfide?
Carbon sulfide. Not in Malaysia, but we got in Singapore.
Oh, okay. What company and the location, please, if you know?
GFC Chemicals, and the location, I'm not very sure.
Okay, maybe because in Singapore we have that, what do we call it? Is it Sembawang or Jurong or I'm not sure. I've been to one industrial area before in Singapore. That was in 2009, 12 years ago, but I forgot the location. So it's highly tightly secure. Okay, it's okay. Thank you very much for the response. Okay, I'm going to proceed to Engineer Dr. Fadli Hakim Binanga. Are you there?
Yes, Doctor.
Okay. Just now, okay, previously we have we learned about the chlorination of methane or methane chloride, right?
Oh, yes.
Right. Okay. So I believe the previous panels, they mentioned about it's very difficult to actually include or embed the chloride into methane because it's methane is CH4 with 4 hydrogen atom, and it's very difficult to remove one hydrogen and replace it with a chlorine. Maybe you can try to explain how what you did in Olefin Malaysia to actually inject the chlorine into the methane? What are the processes? Maybe you have some mechanism that you want to share, the series of reaction.
Okay, nothing. So basically, there are three in the mechanism for the chlorination of methane. There are three steps, in which the first one is the initiation, the chain initiation, in which the chlorine gas will react with UV light, and breaking it into chlorine radicals. Then the chlorine free radicals will then attack the hydrogen in CH4 to produce methyl and hydrogen chloride, as well as, and then the methyl will react with the chlorine gas to produce monochloromethane, as well as the chlorine free radicals. And those two are the second steps, in which it is called as the chain propagation reaction. And lastly, the chain reaction will then be terminated in the chain termination reactions, in which the reaction will remove the free radicals from the system without replacing them with new ones. So there are three reactions in this chain termination reaction, which are the two of the chlorine radicals will react with each other to produce chlorine gas. Next is the methyl will react with the chlorine to produce monochloromethane. And lastly, the methyl will react each other to produce ethane. So that's all for the mechanism for the chlorination of methane.
Okay, thank you very much, Engineer Dr. Fadli Hakim Binanga. So this is really interesting. I'm really interested in what's happening inside the chain propagation reaction as well as the chain termination reaction, because you did mention about the initiation, how the radicals are being formed. Okay, the radicals are being formed, and when the radicals are being formed, it is going to be very reactive because it's unstable. So it want to react with something to stabilize it. So my question is, how do you make the chlorine or the methane to become chlorine radical or methyl radical, meaning Cl star and also CH3 star? So methane to methyl radical, CH4 to CH3 star. Am I correct?
Yes, Doctor.
So how do you trigger it to become a radical?
So for the to make the chlorine gas into chlorine radicals, it reacts with UV light to break the chlorine molecules into free radicals. Then the chlorine radicals will attack the hydrogen bond in the methane. Then it will produce the methyl radicals, and therefore the chain reaction started.
Okay, so meaning that you need to have UV light, then only it can become radical. Is that correct?
Yes, from what I've studied, it needs UV light to become radicals.
Okay, why is it? What will the UV light actually contribute? What actually the UV light do to actually resulted to the formation of radical?
Okay, for that specifically, I still don't know, but the UV light plays a major role to break the chlorine molecules into radicals. But for the specific steps on why can it happen, I think I need to do some more research.
Oh, okay. Okay, does this reaction involve any catalyst?
For the chlorination of methane, for the catalyst, I'm still not quite sure. Maybe the other team members can help. Yeah, the expert members.
Okay, thank you very much. Okay, I
Thank
think
you.
I asked Engineer Dr. Fadli too many questions already. Okay, what about Dr. Amira and Dato Dharmasilan? Maybe can you help Fadli? No? Okay, so maybe,
Doctor,
yeah.
the HZM5 catalyst is used for the chlorination process.
ZSM5 catalyst.
Yeah.
Okay, ZSM5. So that's a zeolite catalyst. A zeolite which actually composed of sodium, alumina, okay, sorry, which sodium, aluminium, okay, and also oxygen. So why? And why the reason? Okay, what's the reason? Zeolite ZSM5 catalyst is being employed for this reaction. What can it do? Okay, what this catalyst can do actually until it can react, until the methyl radical can be formed, until the chlorine radical can be formed. Maybe Datuk Dharma, can you help enlighten? Or maybe you're not sure?
Yes, doctor.
Okay, it's okay, no problem. No problem. Okay, how about Dr. Amira?
I'm also not sure about this catalyst.
Okay, it's okay. So yeah, so the reaction requires catalyst. Okay, the catalyst is very important for the reactants to turn into a radical. Okay, how it can happen? The catalyst must have certain acidity. I believe all panels here have learned this in CRE before, maybe in your third year. Is it in your third year? CRE, Chemical Reaction Engineering. So the catalyst will involve the adsorption, surface reaction, and then desorption. So it is when the catalyst have sufficient acidity, whether it's Bronsted or Lewis acid site, then it can trigger one of the bond from the methane or also the chlorine to become a radical. So it will be removed. So when it becomes a radical, CH3 and CH3, and then it will combine together, okay, to become C2H6. So the rest, so for CH3 and Cl also, it will combine because it needs each other to stabilize. And then when there are a lot, okay, a lot of CH3 radicals, we can call this oligomerization reaction. Okay, it will oligomerize to become a longer chain. Okay, longer higher hydrocarbon. Okay, that's it. Okay, anything? I don't have more question for you guys. Maybe anything? Maybe you want to add? This is free. Okay, Dr. Amira, Datuk Dharma, and also Dr. Fadli. Anything?
Doctor, I want to add about the steam reforming process.
Okay, excellent. Okay, go ahead.
Steam reforming process is a process to produce syngas, and syngas which contain H2 and carbon monoxide, and a relatively small amount of CO2 from methane source. Okay, it works under a high temperature, around 700 to 1000 degrees Celsius, and a pressure range of 3 to 25 bar. Okay, the condition where methane conversion in the reforming process is favored at high temperature due to the highly endothermic nature and low pressure and high steam to carbon ratio. There are some disadvantages for the steam reforming process, which is high energy consumption, high production costs, harsh reaction condition, and low reaction efficiency. And there are some catalysts used in the reforming process. Nickel-based catalysts were commonly used due to the high activity and more because of the low costs. Okay, that's all.
Okay, Okay, so far so good. So the methane steam reforming is actually methane plus hydrogen or plus water.
Methane plus water.
Okay, so the methane steam reforming is actually methane reacting with water at temperature 700 to 1000 degrees Celsius, pressure 3 to 2.25 bar, okay, with the nickel catalyst. Okay, so far that's interesting fact that you mentioned just now. So maybe I can add on to what you have said. Whatever reaction that mentions reforming, it is actually reacting with water. Okay, so whatever reaction that mentions let's say methane steam reforming, okay, when it mentions steam reforming, that is definitely reacting with water. If it mentions methane dry reforming, do you know, Datuk Dharma, methane dry reforming, what the methane is reacting with?
Carbon dioxide.
Yes, correct. So methane dry reforming is actually the reaction of methane with carbon dioxide. If we mention glycerol dry reforming, that is actually glycerol mixed with Datuk.
Carbon dioxide.
Yes, carbon dioxide. So that's the principle. You need to know if it's dry reforming, then it's reacting with carbon dioxide. If it's reacting with, it's a steam reforming, it's just basically with water. Okay, but then the most important thing, when you mention reforming, then the most important products that will appear from the reforming is hydrogen and also CO. Okay, hydrogen and CO. Regardless it's dry reforming or steam reforming, hydrogen and CO will be the dominant product. Okay, so there will of course be some other products such as the CO2 will still be there. Okay, either it is not fully reacted or a product from the consecutive reactions. H2O will be there, carbon will be there. Maybe there will be some traces of low hydrocarbon such as C2H4, C2H6, propane, propylene, and so on. So it depends. So if zeolite ZSA5 is there, so it can further longer the chain. So it can become higher hydrocarbon due to oligomerization reaction. I hope I'm not speaking very fast. Okay, so okay, but then Dato, one thing that actually triggered me to ask you is actually the harsh condition that you mentioned just now. So can you please explain what do you mean by harsh condition for the steam reforming?
Maybe because of the high temperature, the reaction may get more harsh.
Okay, maybe I can add on to that point. Okay, it depends. Okay, it depends what kind of reactor you are using. Okay, if you are using a carbon reactor or a carbon steel reactor or mild steel reactor, maybe it's going to be very harsh internally inside the reactor for those reactions. Mainly because there are some traces, some percentage amount of carbon in the reactor, in the reactor material. So you want to use something that is inert, okay, for this kind of reaction. All right. So when I mention inert, it is actually something like glass, quartz. So it is C. Okay. Not to say C. I mean, it's in an inert form. So it doesn't really easily releases the carbon. So maybe that's one condition. And then when we use carbon steel, mild steel, okay, or normal steel, the internal wall of the reactor tend to corrode. Okay, corrosion can happen due to the acidity the acidic situation of the reaction. That sometimes from the reaction itself, it can provide lower pH, and at the same time, the condition from the catalyst as well. Because catalyst, as I mentioned just now, catalysts also have certain amount of acidity from the Bronsted and Lewis acid side. Okay, have you heard about this? I mean, Bronsted and Lewis? Dr. Amira?
I've heard about it before.
Okay, maybe it was quite a long time ago when you were in your early first year, or maybe before entering the university, you heard about this?
Yes.
Okay. All right. Okay, I think that's all. Okay. Thank you very much, distinguished panel, Associate Professor Dr. Amira, Datuk Dharma, and also IR Dr. Muhammad Fadli Hakim. Thank you very much for your kind sharing with us. Okay. Thank you. Okay.
Thank you,
Thank
Doctor.
you, Doctor.
Thank you, Doctor.
Okay, welcome. Okay, let's see. Okay, so today we have covered, just now we have covered, can you see my mouse there? Okay, so we know about methane, and then we covered the product for, the chemicals that can be produced from methane. Now we are going to move on to the products that can be formed from synthesis gas. Let's see. Okay, chemical based on syngas. Okay, we have 4 wonderful expert panels. Okay, professional technologist Eswaran, are you there? And then we have Eswaran, I believe. Oh, technologist Eswaran is from MUFC. Is that correct? Is that true? Okay.
Yes.
Okay. Okay. You are from directly from Manchester? I believe so. Maybe. Let me. Okay. And then we have Tuan Haji Muhammad Hafizuddin from Shell Middle Distillate, Sarawak. And are you there? Okay. Okay, Tuan Haji, apa khabar? Oh, cannot hear you. Okay, try to solve that. Okay, whenever you try to talk. Okay, and then we have Datin Dr. Nur Aliyah binti Azhar. Where are you, Datin? Oh my God, Datin is here in the house.
Ada.
Ada Datin. Datin is from Dialog Sdn Berhad. Okay, Dialog is a very established, reputable company involved in the oil and gas. Okay, Datin, are you switching on your camera? I'm not
Yes.
seeing. Okay, maybe you are far away from the. Let me just see, searching for you. Okay, there you are. Okay, all right. And then we have from Nigeria, Dr. Nandi Peter Goal. How are you, Dr. Nandi?
I'm fine, thank you for asking.
So it's good to have you. So we rarely have international panel. So now you are here. So we are very happy to have you here. Okay, so you guys are going to discuss about chemical based on syngas. Okay, so I believe all of you are ready for this. Okay, so maybe my first question will be directed to professional technologist Eswaran. Okay, are you there, Eswaran? Yeah, you're there. I
Yes,
think so.
Doctor. Yes, Doctor.
Okay, nice. Okay, can you please just, because just now we have discussed a lot of synthesis gas, so maybe you just discuss briefly very important points. What is synthesis gas?
Thank you for the question. Okay, thank
Dr.
you
Zaki?
for the question. Thank you
Zaki?
for the.
Yeah,
Gas is
continue.
generally gas is generally to be a variable mixture of carbon monoxide and
I think there's some interference. Anybody have the interference that I'm experiencing?
Yes, Doctor.
Maybe are you switching on 2 devices, Eswaran?
Yeah, he's using it.
Maybe you can mute one of it. I think that's the reason for it. Okay, maybe okay, try to do that. Okay. it's not easy to have a person who is in the soccer area working on oil and gas. Okay, go ahead. We cannot hear you. Or maybe there's you need to have that two devices, right? Okay, maybe it's okay. You try to figure out your situation. I'll direct the question to Tuan Haji. Okay, Tuan Haji, maybe you can help answer
Answer the
help
question.
to answer the question.
Okay, can doctor. So synthesis gas is generally considered to be a mixture of carbon monoxide and hydrogen. Carbon dioxide, CO2, and other components such as water may also be present in synthesis gas. So synthesis gas provide a flexible feedstock for a variety of chemical synthesis, which are used directly or as intermediates. Many of these products are used in plastic, synthetic fiber, rubber, and pharmaceutical and other industries. So that's the introduction of synthesis gas.
Okay, so you are saying that syngas can be produced from many sources such as natural gas, coal, biomass, and so on, right?
Yes.
Okay, that's interesting. So basically anything that have hydrocarbon, you can get synthesis gas from there, correct?
Correct, doctor.
Okay, all right. Thank you very much. I'm going back to check out on Eswaran. So Eswaran, are you okay? Eswaran?
Hello, hello.
Yes. Hello.
Yes, doctor, I'm here.
All right. Okay, perfect. Okay, can you share with us, okay, what are the reactions that can produce synthesis gas?
Okay. Actually, there's main three reaction that produce synthesis gas. So the first one is steam reforming, which we react with water, and then the second one is carbon dioxide, which is dry reforming, also oxygen partial oxidation, and also the last one is from the gold gasification to produce the synthesis gas.
Okay. Thank you very much. What do you mean just now when you mentioned partial oxidation? What does that partial oxidation mean?
The combustion process occur with a limited amount of oxygen.
Okay, so how do you control the oxygen?
I'm not very sure, doctor.
Maybe by supplying less amount of oxygen, so a controlled amount of oxygen, so you know the amount of hydrocarbon reactant that you want to enter into the reactor, and then you just calculate and then half the oxygen. All right, so on the oxygen source. Okay, so that's how you can do it. Okay, and then what are the reactions that can take place after the synthesis gas is actually produced? The question is still for Professor Eswaran.
Yes, doctor. Okay, the first one is the water gas shift reaction, which produce hydrogen, and then the second one is Fischer-Tropsch synthesis, which produce synthetic fuels, and then the last one is reaction with methanol, which produce dimethyl ether.
Okay, so there are three. Is it just three reactions or there are more?
There are more actually.
Okay, there are more, but maybe you are highlighting three only at the moment, right?
Yes, doctor.
Okay, so let me just repeat for the benefit of our audiences. Okay, water gas shift reaction, Fischer-Tropsch synthesis, and also methanol. Okay, you mentioned just now that Fischer-Tropsch, okay, can actually produce synthetic fuels. Can you actually okay, let me just ask the next question. Okay, Datin, how are you, Datin? Datin? Are you there?
Yes,
Okay.
doctor.
Yes, Datin. Okay. Can you enlighten the audiences here at our studio? What is actually defined by synthetic fuel?
Oh, synthetic fuel.
Yeah. That is actually from physiotrops. Are you not sure?
Yeah, I'm not sure.
Oh, it's okay, Datin. No problem. No problem. Okay. How about? Okay, I'll get back to you. Okay, later, Datin. How about you, Nandi? Do you know what was meant by synthetic fuel?
I guess it's fuel that's derived from syngas.
Yeah. Okay. Yes. Okay. Do you know what's the carbon range?
The what?
The carbon number range. So methane is C1, ethylene is C2, propane is C3. So synthetic fuel is from what carbon range to what carbon range? Not sure?
I guess maybe from C2. I'm not very sure.
Okay. Um, so from my experience before, when I was studying, I listened to my professor. He mentioned that it was between C5 to C15 or C20. So as long as it depends on the definition. Sometimes it's C5 to C10, C5 to C15, as long as it's in liquid form, and it is hydrocarbon. So that's synthetic fuel. Okay, gasoline range. All right, gasoline range. Okay, let me just get back to Datin. Okay, Datin, I'm going to ask you something here. Okay, throughout the chemical industry, which industry actually dominates the global market of syngas? This is quite difficult question, but I believe you can answer this.
From my research, one report reported that 53% of the syngas is used in the production of ammonia, 23% for the usage in refineries for hydrogen sources, 11% for methanol, 4% for electricity, and the other percentage are for others. Based on region, Asia Pacific is projected to grow at the highest CAGR syngas market between 2020 and 2025, with the ammonia industry dominating the global market. That's what I get from my research.
Oh, okay. So this is new to me. So meaning, from syngas, the most the most popular product that is actually produced from syngas is actually ammonia. That you're saying. Okay. Okay. So and then Asia Pacific is actually one of the biggest player that produces syngas. That's what you're saying as well, right?
Yes.
Okay. When you mention ammonia, what's so special about ammonia? Why ammonia is being produced such massively like that? And then from syngas, okay? So why ammonia? What's so special about ammonia?
I think it's because ammonia is widely used for the production of fertilizer, such as urea.
Oh, okay. Uh, is it just that, or maybe there are something else?
That is the one that I know. I don't know about anything else.
Okay, so I believe there are some other products that can be produced from ammonia. Okay, so urea is one of it, fertilizer is one of it. Okay, there are also certain reactions that we are not going to discuss here that also employ ammonia as the reactant. Okay, and then there are certain analysis, okay, that also employ ammonia You remember just now that I mentioned catalysts have acid side. So when we want to analyze the catalyst acid side, we can or we should use what we call thermal an equipment called temperature program desorption ammonia. Okay, TPD ammonia, temperature program desorption ammonia. And then from that TPD ammonia, we can know the acid side, the amount of acid side, as well as the strength of acid side of a particular catalyst. Okay, so that's actually the utilization, the uses of ammonia is a lot. Okay, so it's okay. So one of it is as you mentioned, urea, fertilizer, and so on. Okay. Okay, thank you very much, Datin. I'm going to direct my next question to Dr. Nandi. Dr. Nandi, okay, you're all right. Dr. Nandi, how rapid is the production of or the development of synthesis gas in Nigeria?
Well, for the development of synthesis gas in Nigeria, it's not quite advanced because the technology is not present in the country. So we don't have any syngas production plants, and the coal reserves in the country are not as abundant. So we don't have enough feedstock material.
But then from my data, mentioned that Nigeria have tremendous amount of petroleum reserve and also natural gas reserve. So do you know any plan that maybe the Nigerian government and also companies are going to develop syngas in the near future?
Yes, the petroleum reserves in Nigeria are quite huge, but then most of it is being exported for refining. But then for the production of syngas, for the companies that may be interested in the future, we have the Power Holding Company of Nigeria, PHCN, because syngas can be used in the production of electricity. So they've been showing interest of trying to produce syngas for electricity production.
Okay, okay. All right, thank you very much. Thank you very much. Okay, Dr. Nandi. I think I am running out of time. We are running out of time. So maybe I think we need to stop team number, the expert panel from session number 4. Okay, unless any of you want to ask something or want to highlight something. Anybody? No? So if no, thank you very much. Okay, Technologies Eswaran, Haji Muhammad Hafizuddin, Datin Nur Alia, and also Dr. Nandi. Thank you very much.
Thank you for having us.
Okay, welcome. It's my pleasure to have you, especially to have Datin here and also Haji Hafiz. So it's a pleasure to have you here. Okay, so let's move on to the next session. Oh, the next session also still chemical based on syngas. So we have 3 expert panels. Oh my God, we have Tan Sri Kisan from BP. We have Professor Dr. Muhammad Nur Iman from UTM. Oh my God, same university like me. And we have Engineer Technologist Nur Firzana binti Azman from Chevron. Okay, who's on the line there? Is that Prof. Muhammad Nur Iman?
Yes, I am.
Okay, so do you have your colleague here, your professor? Tan Sri. Is Tan Sri here?
Tan Sri Kisan. Yeah.
Tan Sri Kisan here, and then Engineer TS Nur Firzana is here.
Yes, doctor. Are you here?
Okay, yeah. We hear you. Okay.
Right.
So the question. Okay, let's move on to the question. Chemical based on syngas. Okay. Since we have the session just now with the previous expert panels about the same topic, chemical based on syngas. So now I'm going to ask a slightly more technical question. Okay. Then the first question will be directed to Tan Sri. Okay, Tan Sri Kisan. Syngas. Okay, just now we discussed a lot of syngas. Syngas is responsible for producing hydrogen, which is important in the production of fuel cell. Okay, everybody knows about this. Okay, hydrogen is used for the fuel cell technology. So what are the differences between fuel cells and the galvanic battery or voltaic battery? Tan Sri, over to you.
Thanks for the question, Doctor. And first
Oh,
of
we
all,
cannot hear you.
thanks for the question, Doctor.
Or maybe there's some technical issues. Tan Sri, we cannot hear you. Okay, maybe while you sort out your problem, I'm going to direct the question to Prof. Iman. Prof. Iman, can you help to respond on that?
Okay, so in order to answer your question, Doctor, so what's the difference between the fuel cell and the galvanic battery or voltaic battery? So fuel cell is actually it generates energy and directly converts an energy source into electricity through a chemical reaction. And also one step rather than multiple steps, and also that it allows fuel to remain the efficient and quiet and clean. So for the battery and voltaic battery, it difference with the fuel cell, which is it stores energy, and it is a device that contains 2 or more electrochemical cells that can convert chemical energy into electrical energy directly. So yeah, so that's the difference between the galvanic battery and voltaic battery.
Okay, in much simpler words, how can you describe it? Because the way you describe it is quite technical, so maybe you can simplify.
Oh, so basically that fuel cell it produces energy, while battery it stores energy, and fuel cell can be used for a long period of time, but battery very short period of the time.
Okay, so that's better. Thank you very much, Prof. So that's why we need professor like you. Okay, so the next question will be, okay, I let me see whether Tan Sri, are you okay now? Tan Sri Kisan, we cannot hear you. Tan Sri?
Can you hear me, Doctor?
Yes, we can hear you finally, Tan Sri. So how are you doing, Tan Sri?
Sorry, fine, Doctor. Sorry for the inconvenience.
It's okay. So you are you okay now?
Yeah, I'm okay, Doctor.
How's business?
Yes, Doctor.
Business okay?
Yeah, so far everything okay, Doctor.
Okay, that's what we want to hear. Okay, so this is like a trying time due to the pandemic, so we want to hear that you are having a good business. Okay, let's see. Okay, I'm going to ask a question. Okay, regarding the concerning methanol and also the natural gas. Okay, so what's the difference between the old and the new ICI process in production of methanol from natural gas? So I repeat back again, what's the differences between the old and new ICI process in the production of methanol from natural gas?
Okay, Doctor. Thanks for the question. Basically, the process is almost the same, but the catalyst and the pressure and the temperature is slightly different compared to the both old process and ICS process.
Okay, how different?
As for the ICS process, it consumes low pressure, which is around 50 atm, while for the old process, it's around 270 to 420 atm.
Can you repeat back again the temperature?
Okay, so for the old process, the temperature is around 270 to 420 atm, while for the ICS process, it's 50 atm.
Okay. All right. So there's a significant difference in terms of temperature, the reaction temperature, right? Okay. Thank
Yes,
you.
Dr. As for
Thank
the
you very much, Tan
process-wise,
Sri.
it's almost same.
Okay, Tan Sri, thank you. I'm going to ask the next question to IRTS Nur Firzana. Okay, are you there, Firzana?
Yes, doctor.
All right, okay. Thank you very much. Okay, what are the typical chemicals used to scrub CO2 from syngas?
Okay. Basically, there are a few chemical that been used to scrub the what again? I forget.
The carbon dioxide.
The carbon dioxide. Sorry. So there are methyl diethanol amine (MDA) as well as select sol technology.
Okay, so have you actually explained that technology inside your one-page note?
I don't think so. It's just like I think we just
Okay, no problem. Okay, team 5. I'm sorry. Due to time constraint, I didn't realize that actually time is moving very fast when we are doing this talk show. So so I'm sorry because I really managed the time badly now. Okay, and we have Tan Sri, we have Prof, we have IRTS Nurfizana, but then we cannot ask further question. But I hope you guys will fulfill our invitation soon in the coming weeks. Okay, so we will invite you again. Okay, thank you very much. Okay, Tan Sri, Prof,
Thank you very much, Dr.
and
Okay,
also
thank you for VS.
engineer. Okay, thank you very much. Okay, let's move on to the next. So we have heard just now synthesis gas production, which are some of the chemicals here. So now we are going to move on to the ammonia based chemical. Okay, so let's see. We have team number 6. Okay, with Sir Mani Bharati from Halliburton, Dato IR Muhammad Haziq, and also PM Dr. Nurin Wafa. Are you there?
Yes, doctor.
Okay, PM Nurin is from Xiamen University. This Xiamen University is in Klang Valley, okay, not the one in China. And Dato IR Muhammad Haziq is from Aramco in Pengerang, Johor, not Aramco in Arab. Okay, all right. Okay, so I'm going to ask question, okay, to team 6. Okay, the first question is directed to Sir Mani Bharati. Okay, are you there?
Yes, doctor.
All right.
Sure.
Okay, so we have covered a little bit of ammonia in the previous session just now. So now we are going to learn more about ammonia. So maybe can you explain what are the direct application of ammonia?
Okay. Thank you for the question, doctor. So basically, from actually, direct application for ammonia is by injecting them to the dry soil. If you see in the country United States, we apply the soil from tanks, the liquid gas of ammonia.
Besides that, okay, so that the injecting anhydrous ammonia to the dry soil is one point. Besides that, any other application of ammonia that you know, that you are aware of?
Ammonia is also,
Okay.
as long as I know, ammonia is also in fertilization processes.
Okay. All right. Okay, thank you very much, sir. I'm going to move to Dato. Dato, are you there?
Yes, Doctor.
Okay, Dato'. Okay. Okay. This question is also related to ammonia. Okay, but then the application until it becomes fertilizer. Okay. So how the cake, okay, how the cake is formed in the urea fertilizer process. Okay, how the cake is formed in the urea fertilizer process, and why it is the least preferred from the product.
Okay, before that, as you know that urea is one of the chemical base from ammonia. So why the cake is formed? Most fertilizer have some tendency to form lumps of or agglomerate during storage. So caking is one of the most challenging issue that granular fertilizer producer face. This serious problem causes complicated effect that can threaten to degrade the product quality, cause dust issue and safety hazard, and also can spoil the product.
Okay, so meaning the caking is actually not helping out the equilibrium, the property of the soil. Is that what you're saying?
Actually, caking is more to the problem in storage. When the caking process occur, the fertilizer become more sticky and it also become harder to store and to transport the fertilizer.
I see. Okay, okay, noted. Okay, thank you, Dato', for that information. Okay, I'm going to move on to Dr. Nurin. Are you there, Dr. Nurin? I'm not seeing Dr. Nurin. I think Dr. Nurin is there. Ah, okay. Now I can hear your voice. Okay. Just now we have discussed a lot about ammonia, urea, and so on. Okay, but then now I'm going to shift to alkanoamine. Okay, alkanoamine. So alkanoamine is also one of the important products that can be obtained from ammonia. So can you please explain a little bit about what is alkanoamine and also how and why it is important to the industry?
Okay. So alkanoamine is
Can you speak louder, please? Agak kurang jelas.
Dengar tak, Doktor?
Ah, okay, good.
Hello? Okay. Alkanoamine is a chemical compound that contains hydroxyl and amino, and alkanoamine is class term, sometimes used as a sub-classification, and process for producing alkanoamine is ammonia to obtain a reaction product containing monoalkanoamine, dialkanoamine, and a trialkanoamine.
Okay, so how alkanoamine is important? Why? What's the uses? What's the application?
Or the application. So alkanoamine has been used in it is antimicrobial and antifungal activities, and in the deletion of the physicochemical properties of molecules. It is used as the carboxylation catalyst to synthesize materials because they have a very, and it also uses alcohol. So is a particularly good industrial emulsion we can use to produce and emulsions and functional fluids.
Okay. All right. Thank you very much. Just now the line was not really favoring you. I don't really hear all the versions, all the application version that you mentioned. But hopefully after this you can highlight this. Hopefully it is available in your one-page note. Okay. So I want to ask more questions, but I have no time left. So Sir Mani, and also Dr. Nurin, I'm very sorry, Okay, so maybe we have to end this now. I'm going to ask question. Maybe I'm going to invite you again in other sessions. Okay. So
Sure, Doctor.
so hope to see you soon in maybe week number 11 or 12. Maybe we'll meet again. Okay. Hopefully. Okay. Thank you very much. Session expert panel number six. Okay. Thank you very much. So I'm going to move on.
Doctor.
Welcome. Okay, now we are going to the next panel expert, still on chemicals based on base ammonia. Sorry, this is my bad, wrong spelling. So it should be chemical based on ammonia. Okay, so we have here Engineer Dr. Muhammad Irshad, IRTS Nadia Nabila, and also Dato Navin Raja. Okay, are you all there?
Yes, sir.
Yes, Doctor.
All right, perfect. Good. So you are team number 7, right?
Yes,
Doctor.
Okay. Okay. Here's the first question, and I'm directing this question to Engineer Dr. Muhammad Irshad, okay, from BEM and IEM. Okay, representing BEM and IEM. So first, okay, just now we have our previous panel. We asked about some of the products, ammonia, urea, alkanoamine, but then we haven't had the time to discuss about hydrazine. Can you please explain what is hydrazine and why it is important? Okay.
Okay. Let me open a little bit my note. Okay, so hydrazine is one of the chemicals that you can get from ammonia. I'm not really expert on how you produce hydrazine from ammonia, but it does have a few good functions. From what based on my knowledge and from my research, hydrazine are used in rocket propulsion because during, if I'm mistaken, during World War II, where all the Civil War, all the Cold War, and everything. So hydrazine is one of the earliest fuel that used in rocket propulsion, and it's proven to be a successful fuel. But if I'm not mistaken, if hydrazine is still to be used right now in the rocket fuel, and other than as a function in rocket fuel, hydrazine also used as a forming agent in preparing polymer foams. So forming agent, if I'm not mistaken, is you want to make the foam lah. You want to make the material to be to have a puffy like look. And then other than that, hydrazine is also an active ingredient in insecticide and herbicide and certain and other product that used to kill insect or maybe unwanted plant in your crop and something like that.
Okay, do you know the chemical formula for hydrazine?
I'm not sure about that.
Okay, maybe, okay, thank you, Dr. Irshad. Maybe Engineer Nadia or Datuk Navin Raja can help the chemical formula for hydrazine. Any of you know?
Okay, I can
Maybe
help on
you
it,
can.
Doctor.
Pardon?
I can help on it, Doctor, for the hydrazine molecule formula.
Yeah, molecular formula, hydrazine.
Okay, so it's basically N3H4. It's
N3H.
N3H4.
Okay. Okay, thank you very much, Dato. Do you produce the in Talisman, since you know this?
Yes, we do produce this. We have two types of process for production of hydrazine, which is the oxidation of ammonia by using the Reschik process. And this process is basically is the original commercial production for the hydrazine, which involves oxidation of ammonia to chloramine with sodium hypochlorite, and also for the reaction of chloramine with the excessive ammonia and sodium hydroxide to produce an aqueous solution of hydrazine with the sodium chloride as a byproduct. And also we also have another process for the production of hydrazine, which is the PARC process. and also known as peroxide process 2.
Can you
This process?
Sorry, Dato' Naveen. PAC, how do you spell that? PAC?
PUCK.
PUCK. Okay, the PAC process. The
Yes,
PAC
doctor.
process. Okay. All right. Thank you very much.
So, okay, doctor. So basically, this process is the hydrogen peroxide is used as an oxidant instead of sodium hypochlorite, which is a traditional used to generate hydrazine. The main advantage of the peroxide process is to hydrazine, and relatively to traditional oil Rashik processes, the previous process, it does not co-produce salt.
Can you
This
hold on a
process.
while? Hello? Yes? Yes? Ini saya buat dalam talk show. My students, yes. Yes, all of them are students. I just, okay. Hello, are you still there?
Yes.
Okay. Thank you, Dato' Naveen. Okay. Where were you just now? I'm sorry about that.
Previously I was in the PAC process.
The
production of
process.
hydrazine.
Okay. Okay, so you just explained the PAC process, which is the ammonia reacting with hydrogen peroxide, right?
Yes,
and then,
true, doctor.
And then produce the N3H4, which is plus water. Okay, so basically to produce hydrazine, there are two. You are saying that there are two processes, which is Raschig process as well as the PAC process, correct?
PAC process, yes, true, doctor.
So meaning in simpler terms, the ammonia plus hydrogen peroxide is PAC process, and then the ammonia plus sodium hypochlorite is actually the Raschig process. Okay.
True.
But then for the Raschig process, the hydrazine is being produced plus the sodium chloride and water, correct?
Yes, true, doctor.
All right, amazing, Dato'. Thank you very much, Dato'. Okay, I
Thank
want
you,
to ask to Engineer Nadia. Okay. What is the name process that involve? Because we have discussed about ammonia just now. So what's the name of the process involved to produce ammonia? This is very simple.
Haber process.
Haber process. Okay. Can you explain about Haber process? More about Haber process?
So the Haber process is from the nitrogen from air is combined with hydrogen from nitric gas, which is methane. In the ratio of 1:3, with the temperature of 400 to 450 degrees Celsius and pressure at 200 atm, and the catalyst is iron. And then after produce, the gases will be cooled and ammonia will be turned into liquid.
Okay. So how many moles of you're saying just now? How many moles of nitrogen and hydrogen?
The ratio is 1:3.
1 to 3.
By volume.
1, 3. Right. 1, 3. Not 1, 2, 3.
1, 3.
1, 2, 3. Okay. So and then we can produce ammonia. So meaning one is nitrogen, hydrogen is 3. Okay. So then we can have NH3. Okay. Back to Dr. Irshad. Okay, Dr. Irshad. Your smiling is killing me. Okay. Can you just explain what's the function of ammonia in the refinery?
Ammonia is not directly used in ammonia does have a good function in refinery, but it does not use directly in the refinery or gas purification. But first,
Alright.
the ammonia first need to convert it to alkanolamines, and then the alkanolamines will be used in gas purification system to remove acidic gases such as carbon dioxide and hydrogen sulfide from the gas stream in natural gas as well as in refinery industry.
So you mean it's like an absorber to absorb acidic gas, toxic gases?
Yes, I think something like that. The technology is about like gas absorber or maybe like solvent, like a solvent, something like that.
Okay. So this is actually useful for environmental control, right?
Yeah.
Okay. All right. Thank you very much. I didn't notice that actually we can use ammonia to produce alkanolamine, and then we can use it as absorber. Oh, okay, something like that. So okay, that's interesting to know. Back to Engineer Nadia. Okay, I know you are very eager to answer me. Okay, why ammonia is a very popular I repeat that again. Okay, why ammonia is so popular to be used as fertilizer production? We cannot hear you.
Okay.
Okay, all right, good.
Because ammonia has highest N content, which is good for the fertilizer, and to grow the plant, so it needs three types of nutrient, which is nitrogen, phosphorus, and potassium. So that's why ammonia is important for the fertilizer.
Okay, I have a trick question now. Okay, when I was small, when I was a little kid, okay, and then that time my father was washing his car, okay, and then there's a lot of soap, okay, water and soap, and then the water and soap, I take it, or some of the remaining water and soap fell down on the floor, and then I collect it or I sweep it to the grass and also to some of the plants. Okay, so far do you understand the situation?
Yes.
Okay, so then I asked my father, okay, Ayah, if we pour this water and soap, the soapy water, into our plants, what will happen? Will the plant die? That time I was quite small, and then I thought, I have the thinking that the plant will die, because imagine the plant is me, and then if I drink soapy water, definitely we will die, right? Soap plus water. So, and then my father mentioned, no, the plant will grow nicely, perfectly. Okay, the plant will have no problem when we put in the soapy water plus soap. Okay, so and the soap water will contain, of course, will contain some traces of some compound of ammonium compound. Okay, so can we actually relate that ammonia fertilizer with the soapy water? That's my question. Actually, I wanted to ask to tell a little bit story, but then try to relate this to the situation of the ammonia as fertilizer.
Which panel are you asking?
Oh, I'm asking. Okay, now I'm asking the three of you. So anyone can answer.
Okay, I want to try.
Okay.
Okay, despite ammonia is being used like largely in the fertilizer, in the agriculture industry, like if I'm not mistaken, about 80% of ammonia globally produced is used as fertilizer. It is used in agriculture, but it's really really common. You can found commonly ammonia in your household product, especially in the cleaning product. So you can, such as the soap that you have mentioned. So considering that ammonia presence in the soap and you mix it with the water, so I can say that the ammonia does provide the nutrient, the nitrogen nutrient to the grass that you serum on the grass.
Yeah. You're right. So that time it doesn't make sense to me, but now, I mean, after we know, we learn. That's why knowledge is very important. So when we know that nitrogen is there to actually enrich or give nutrient to the plant, so it's okay. So we can put soap or anything to the plant, so it will grow nicely, right? Okay, guys, thank you very much. It's a pleasure to have you, all of you here. Okay, Dr. Muhammad Irshad, Engineer Nadia Nabila, and also Dato Navin Raja. Dato, I hope your talisman stock will be okay. But I know it's a desperado time, but hopefully it will be okay, right? Okay.
Hopefully fine, doctor.
Thank you very much, guys.
Okay, thank you, doctor. Thank you.
Okay, move on to the next team. Okay, so just now we covered a lot already. So chemical base, let me scroll. Okay, we covered the chemical base from methane. Okay, the second and third team, and then chemical produced from syngas, and then we just covered the chemical base produced from ammonia. Okay, we have urea, we have hydrazine, alkyl. I'm very difficult. I'm very hard to pronounce this alkyl amines. Okay, alkyl amines. Again, methyl amines, hexamethyl tretramine, and so on. Oh, I'm sorry about that. My bad. Okay, there are many chemicals that can be produced from ammonia, but then we just managed to cover a little bit. So we just covered urea, hydrazine, alkyl amines a bit. Okay, so the rest, maybe after this you can look at the one-page note inside e-learning. Okay, download, and then you can see, you can read. Okay, so now I'm going to move to the next theme. Okay, okay. We are going to discuss chemical based on methanol. So now we are at the last part. Okay, chemical based on methanol. Okay, if you see here, chemical based on methanol. So those are the chemicals: formaldehyde, acetic acid, until gasoline, MTG. MTG stands for methanol to gasoline. Okay, and we have here our moderators. So I'm the moderator. I'm the host. Okay, we have here Hajah IR Nurul Ashikin. Are you there? From Petra.
Yes, doctor. Yes.
Okay, Hajah, how are you, Hajah?
I'm fine.
Okay, Hajah. Okay, Hajah is looking good there. All right. So this is a very young. Okay, and then we have Dr. Shiva Neswar and from Sakura Energy, and we have Dr. Siti Nur Aisyah from NPRC. Okay, so I'm going to ask a few questions. Okay, for this first round. Okay. So I hope everybody is doing good. Okay, first, this will be directed to Hajah. Okay, Hajah. We know that methanol can produce. Okay, let me just go back here. Okay, we can see methanol, right? Methanol can produce many things, many compounds. Okay, so my question is, based on all the chemicals that can be produced from methanol, which one is the most important one, in your opinion?
Okay, thank you for the question, doctor. For me, formaldehyde is the important one because formaldehyde is the largest consumer of methanol, accounting for 25.1% of the 98.3 metric ton of methanol produced in 2019. Formaldehyde is a highly versatile chemical intermediate used in the production of many strategic important products. Other than that, methanol also produce a lot of things. For example, uh, formaldehyde used to formaldehyde act as a preservative to kill microorganisms in the personal care and consumer product. Formaldehyde also used in chem manufacture, explosive, plastic, and artificial material. And formaldehyde also one of the essential component of the modern petrochemical industry.
Oh, okay. So there are plenty. Okay, you really describe a lot. Okay, thank you very much, Haja. So there are many chemicals, but then maybe as we see here, there are many chemicals: formaldehyde, acetic acid, methyl ester, methyl chloride, methyl amines, Mtbe, gasoline, Mtg. Okay, but then Haja just now mentioned about formaldehyde. Okay. Okay, thank you, Haja. So from her explanation, we can see that formaldehyde production from methanol consists of 25%. Okay, so meaning 25% of all, okay, that means of all the products that can be produced from methanol, formaldehyde consists of 25%, correct?
Yes.
Yes, yes, okay.
The largest among the other chemical.
Okay, the largest among the other chemicals produced from methanol. All right, thank you very much, Haja. So I'm going to move on to Dr. Shiva. Are you there, Dr. Shiva?
Yes, doctor. Yeah.
Okay, Dr. Shiva. Wow, you look quite fresh there. Okay, okay. Since Hajjah just now mentioned about formaldehyde, can you just please explain to us, share with us, okay, what's the chemical formula for formaldehyde? And also, that's the first question. And then the second question, maybe you can help enlighten us about, okay, I think I let you answer the first question first. The chemical formula.
The chemical formula for the formaldehyde will be CH2O.
CH2O. One carbon, two hydrogen,
One carbon,
and
one
one
hydrogen,
oxygen.
one oxygen. Yes.
CH2O. Okay, formaldehyde. Are you actually selling or producing formaldehyde in your company, Sapura Energy?
Sapura is based on oil and gas company, doctor.
Oh,
So,
okay. You don't produce that. Okay, okay. All right, thank you. Okay, here comes my next question. Okay, as we know, methanol is used to create fuel. Okay, as we know, methanol is used to create fuel, solvents, and antifreeze. So what is the usage and benefit of antifreeze?
okay, so as we all know, methanol has a chemical properties which allow it to lower the freezing point of a water-based liquid and increase its boiling point. So these attributes lead methanol to be used as antifreeze in a windshield washer fluid to keep the cleaning fluid from freezing, which may let them to keep flowing without freezing. And it also can be injected in natural gas pipelines where it lowers the freezing point of water during oil and gas transport. So it usually enhance the freezing point, which means that the liquid will not freeze easily.
Oh, okay. So meaning, for example, at North Sea, UK, it is very cold, harsh weather. So in order to transport the crude petroleum from offshore to the land in the pipeline, you also inject formaldehyde. Sorry, you inject antifreeze inside there so that the petroleum will not freeze. Is that correct?
Yes, doctor. Somehow it's also related to oil and gas terms like pour point, which also defines as the lowest temperature to become a crystal. So they usually inject this antifreeze to enhance the freezing point.
Okay, okay, noted. Okay, okay. Thank you very much, Dr. Shiva. I'm going to ask the next question to Dato Dr. Siti Nur Aisyah. Are you there, Dato?
Yes, doctor.
I cannot see your face. Oh, there you are, Dato. Okay. How are you, Dato? Are you healthy? Fine?
I'm fine.
Okay, good, good, excellent. Okay. I have a very, very simple question because, okay, we are having methanol now. Okay, we're having methanol. Methanol is like the third layer of, after methane. Okay, then we can get methanol. Okay, if we want to get ethanol, okay, from methanol to ethanol, how can we convert methanol into ethanol? Because ethanol is also very, very important commodity product. Ethanol can be used as fuel. It's almost similar to gasoline. Okay, almost similar to gasoline properties. So maybe you can help us explain, Dato'?
Okay, doctor, so basically you ask how to convert from ethanol to methanol or methanol to ethanol?
From methanol to ethanol. Because we have methanol now, right?
Oh, okay. So from methanol to ethanol, basically it is a process that require oxidation process which will convert the ethanol into acetic acid, followed by the treatment with ammonia, which will give ethanamide. And then it will undergo the degradation process, which will produce methanol.
Okay, so actually you are explaining about ethanol to methanol, right?
Yeah.
I was asking how to convert from methanol to ethanol, not from ethanol to methanol. But it's okay. So just now you mentioned about converting ethanol to methanol, right? Okay. So ethanol, when we want to convert ethanol to methanol, of course we need to remove the oxygen and also hydrogen. So it will involve some deoxygenation as well as dehydrogenation, or maybe a combination with dehydration. Okay, we want to remove the oxygen and hydrogen atom. Okay, so that's actually a way to do it as well. But then it's okay. You mentioned about ethanol to convert to methanol, so that's fine. So it involves converting the ethanol to acetic acid, which is CH3 CH3OH, right? Acetic acid. All right. Okay, thank you very much. Let me see the time. Okay, I think the time is not on your side and our side. So I'm terribly sorry about this, but then I know I have listed a lot of questions here, but then I have two more teams to entertain, so I have to maybe leave you now for now. So I'm very sorry, Hajah, Doctor, and Dato'. So maybe we meet in week 11 or 12, okay? So for our next session that time. Okay, so thank you very much. See you later. Okay, welcome.
Thank you, Doctor.
Thank you. So we'll move to the next expert panel, still on chemical based on methanol. Okay. So here we have our panels, and our panels here are Engineer Faras Amari Ghazi from Technip. He's an Indonesian working in Technip Malaysia. And we have Dr. T.S. Pavitra from Valesto Energy. And we have Datuk Siti Nurhaliza. Oh my God. Datuk Siti Nurhaliza. Are you there? From Dayang Enterprise. Datuk. Okay, we have the Faras. Is that Faras? Are you there? Okay, Faras. And then Khaliza, Datuk Siti Nurhaliza. And then, where's Pavitra? Pavitra, where are you? Okay, hopefully you are there later, okay? Okay, I'm going to ask the first question. There, all right, okay. Okay, so you are also studying chemical based on methanol, okay? Ignore the title there, so it was my typo error. Okay, chemical based on methanol. So, okay, I have a very, very interesting question to ask. Methanol, okay, this question is directed to Faras, okay, Engineer Faras. Okay, methanol is actually present in liquid form, correct? If
Yeah, doctor.
methanol,
Yeah,
okay,
doctor.
okay, methanol is present in liquid form, and when it is in liquid form, it's not that dangerous to human, to us, okay? But then if methanol is present in gaseous form, what will happen? Is it dangerous?
If methanol is in gas form, it also dangerous for our respiratory, because there is a chemical substance that harmful for our for our
respiration system.
Respiration system, yeah.
Okay. So I realized this because last time when I was doing my master's, I actually vaporized methanol. I vaporized the methanol because I was actually doing some reaction in my lab. And then I happened to actually inhale the vaporized methanol and I feel sick. I immediately drank a lot of milk to actually neutralize my body. So actually vaporized methanol is very, very super dangerous. Okay, it's not as dangerous, as toxic as hydrogen cyanide, but then it's still equally dangerous. Okay, so we need to be very careful if we are dealing with vaporized methanol. All right. Okay, thank you very much, Engineer Faraz. I'm going to move on to Dr. Pavitra. Oh, how are you, Pavitra? Why is so dark there? Is it rainy? Oh, we cannot hear you. Your mic maybe is switched off.
I'm in UTM
okay,
actually.
so okay, we can hear you. Oh, okay, yeah, same here. I'm also in UTM. Okay. Okay, Dr. Pavitra from Valesto Energy. I'm staying in UTM now. Okay, let me ask you one question. Okay, one of the chemicals that can be produced from methanol is Mtbe, right? Mtbe. Can you please explain what is Mtbe and what is the application for Mtbe?
Mtbe is actually methyl butyl ether. It is used as octane booster and oxygenate in gasoline or intermediate to produce isobutylene. Octane booster is actually something that increases the octane rating of fuel, which enhances the vehicle's performance. As for oxygenating the gasoline, it can be said that Mtbe acts as the gasoline's additive to reduce carbon monoxide and soot produced from combustion of the fuel itself.
So it's Mtbe, which is methyl butyl ether. Okay, it is actually injected together with the fuel, is it? With the gasoline to improve octane number. Okay.
Yeah.
And then if we don't have Mtbe inside our gasoline, it will produce more soot.
Yeah.
Is it true? Soot. Okay. For the benefit of our audiences, can you explain what is soot? S-O-O-T? Is it S-O-O-T?
Yes, doctor.
Okay, can you explain what is actually soot? S-O-O-T.
From what I understand is that soot is some kind of black residue that is produced when a high carbon fuel is being combusted. That is what I understand. It's a black residue that is left behind from the combustion process.
Yeah. You're right. So it's actually a black residue, okay, like maybe sometimes it originates from smoke, okay, from combustion, and then it releases some fumes, smoke, and so on, and then it leaves black traces. Okay, thank you very much, Dr. Pavitra. Okay, let's move on to Datuk Siti Nurhaliza from Dayak Enterprise. Datuk, are you there?
Yes, sir.
Okay, Dato, I know you are very excited. Uh, okay, just now we mentioned about MTBE, but another product that can be obtained from methanol is actually TAME. Can you explain what is TAME and what's the application of TAME?
So basically, TAME is stand for the third amyl methyl ether,
Can you
and it's
repeat again?
third amyl methyl ether.
Third amyl methyl
Methyl
ether.
ether.
Okay,
Yeah.
okay.
So
All right.
so basically, it can be used as the fuel surgeonate, and basically, steam, IC55 steam, it actually ether that can be derived from the simplified distillation fraction of naphtha. And so for this one, I can just simplify in the
Okay, thank you, thank you. So meaning TAME, TAME, we can obtain from just now you mentioned from naphtha, from the distillation, from the fractional distillation of naphtha.
Yeah, C5, the one, huh?
Okay. Do you have the chemical formula for TAME?
So basically, to produce steam, what when I do research, there is two types of isomer, which is first 2-methyl butene, 2-methyl but 1-ethene. It will react with the methanol and produce steam. And second one is 2-methyl but 2-ethene, react with the methanol, can produce steam. Basically, the two chemicals has the, I think it's just the difference of isomer, which is one with the 1-ethene and second one with 2-ethene, and
Okay.
it still can produce the same thing.
Okay, it's good that they have the isomer, but then can you just give the chemical formula?
Chemical formula.
Do you have the
Maybe
chemical
like
formula for TAME? And then maybe Dr. Pavitra, can you also give the chemical formula for MTBE?
So I'm answering for the team. Basically, chemical
Okay.
formula is C6H14O.
C6H14 H1414O. Right.
H14.
Okay. Thank you. Okay, thank you very much, Dato, for answering. Okay, maybe I move on to Pavitra, to Dr. Pavitra. Okay, Dr. Pavitra, what's the chemical formula for MTBE, please?
It's C5H. No, it's actually CH3, which is connected to one carbon molecule and then OCH3. Because it's
You don't have
butyl
to mention.
ester.
You don't have to mention the
That's
structure.
why.
We are just interested to
Uh-huh.
know C XX H XX O XX. In terms of that. So when we ask about chemical formula, you just mention that. So you don't have to
Okay.
mention C and then the branch, the polymer.
C5H12O.
C5H12O.
Yeah.
Okay. C5H12O. Are you sure?
Yes.
Okay. It's okay.
That is
Thank you
what
very
I
much.
wrote.
Okay. Huh?
Yeah, that is what I found.
Okay, okay. Thank you, Dr. Pavitra, for highlighting that. Okay. Okay, I will just ask one last question for the three of you. Anybody can answer. Let me think. Oh, I'm thinking too long. Okay. Hold on, I'm trying to search more interesting question here. Okay. Okay. The question is, do we need methanol? Do we need methanol to produce biodiesel? Anybody can answer. Okay, I rephrase the question, or I add more detail. Do we need methanol to produce biodiesel from palm oil? Okay, anybody can answer this? This is actually what you have done in your second year laboratory CRE at N16 lab. Do you guys use methanol that time?
Yes, doctor.
Or maybe a lot
We
of
used
forgotten.
we methanol. Sorry. Okay. Methanol is used as an alcohol for the trans-esterification reaction between the palm oil and the alcohol to produce the biodiesel. But it is more recommended to use ethanol rather than methanol because ethanol produces more yield compared to methanol.
Okay, all right. So that time, when you were doing your laboratory, you are using ethanol or methanol?
We used methanol.
Methanol. Okay.
Yeah.
Because simply it is cheaper than ethanol.
Yes.
Okay. And then you use minyak cap buruh. Is it? If you still
Mm,
recall,
yes,
I don't
doctor.
understand, and I don't know why the technician decided to use minyak cap buruh while they can also use different types of oil, cooking oil. But then they specify, they claim that using minyak cap buruh it's good, it's better than using the other types of oil. Okay. Okay, then thank you very much, team number 9 for participating and helping in our processing tonight talk show. Okay, so thank you very much, Arfaras, Dr. Pavitra, and also Datuk Siti Nur Haliza. Okay, see you. Okay, let's move on to the last theme, alternative methods of obtaining methane. Okay, so this is going to be quite interesting. We have 4 expert panels. Okay, Engineer Sarmila, anak perempuan Ellen Govan from Murphy Oil. And then we have Dr. Muhammad Haikal bin Mokhtar from ConocoPhillips, Engineer Mufreh Ali Abdul Rabu Alashi from Qatar Gas. We import him from Qatar Gas. Okay, and Dr. Vilma Raj, anak lelaki Tiru Van Gadam from Saudi Aramco. Okay, are you there, all of you, panels?
Yes, doctor.
Yeah, doctor.
All right. Okay. Oh, I can see you guys are quite excited now. You awaited your session from 2 p.m. just now.
Yes, doctor.
Okay. It's okay. It will end soon. Okay. Okay. I'm going to ask the first question to Engineer Sarmila. Can you please just explain to me, not to me, to the rest of the audiences, okay, in the studio, okay, what are the alternative methods of obtaining methane? Any other methods? Okay, because just now we learned and explored the methods of getting methane from petroleum sources, from natural gas. So is there any other sources of getting methane?
Yes, thank you for the question, doctor. Actually, we have 2 alternatives. The first one is the production of methane from biogas, whereas the second reaction is the Sabatier reaction.
The what?
For the
Sabatier.
Sabatier reaction.
Okay, Sabatier. Let me just spell it slowly so that the others can also know. Sabatier, S-E-B-A-T-I-E-R. Sabatier reaction. Okay, all right, continue.
Okay, so for the first reaction, which is from the biogas, it is actually a gradual process which starts from volatilization, biological decomposition, and then chemical reaction. So it is produced from anaerobic reaction. To be more specific, organic matter will be decomposed in the absence of oxygen. So the raw materials could be plant material, um, agricultural waste, green waste, or food waste. And for the subbacterial reaction, it involves carbon dioxide and hydrogen as the raw material, and then it will produce the methane and water in the presence of catalysts such as nickel. So these are the two reactions, Doctor.
Okay, so I'm interested to know about Sabatier reaction further. Okay, thank you, Engineer Sarmila. So
Thank
I
you.
think I'm going to ask the detail about Sabatier reaction to Dr. Haikal from ConocoPhillips. Are you there, Dr. Haikal?
Yes, 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 Doctor.
Okay, Dr. Haikal,
Yeah.
I understand that, okay, can you just please explain further in a little bit detail about Sabatier reaction?
Oh, okay. So, thank you for the question. So, Sabatier reaction is actually a chemical reaction that produces methane and water from a reaction of hydrogen with carbon dioxide, and at a certain temperature and pressure. The temperature is around 300 to 400 degrees Celsius, and the reaction is isothermic reaction.
Pardon, the pressure is what?
The pressure is not specified, but the temperature is around 300 to 400.
Does it involve any catalyst?
As far as I'm concerned, yes, which is solid state nickel.
Oh, okay, solid state nickel.
Mhm.
Okay, okay. Okay. This is very interesting because last time when I just graduated, I purchased a bag of nickel, a bag of nickel chloride from China. So I still remember the nickel which is in solid form, and the color is very, very bright. So my question to you back again, Dr. Muhammad Haikal, what
Yes.
color is the nickel? What color is nickel's solid state nickel catalyst? I can see that. Who's that? Roommate, eh?
The lecturer from UTM just now, Doctor.
Oh,
Uh,
okay. All
okay.
right.
Answering your question, I'm sorry, Doctor, but I didn't have the information for that.
Okay, you're not sure. Okay.
Yeah, yeah.
Okay. I'm gonna ask to engineer Mufre. Mufre, are you there?
Yes, I'm here.
Hey, Mufre, how are you?
Yeah, Alhamdulillah, I'm good.
How's
How are
the
you?
how's the weather at your place now?
It's very good. A little bit cloudy.
Okay. You are in Malaysia or in Qatar
Yeah,
or Saudi?
yeah, in Johor.
In Johor.
Malaysia.
Okay.
Malaysia.
Okay. I asked Dr. Haikal just now about the color of nickel. Do you know the nickel color? What
Yeah,
color is nickel?
it's a metallic color, almost silver, shiny silver color.
Really?
Yeah. Recently I saw a video and they were using like a silk material, and they said it's nickel. They use it in the catalyst as a catalyst, and it looked like that, like a silvery shiny color.
Okay. Yes. If it is solid state nickel, then it can be silvery shiny. But then if it is like a nickel salt, which means it is nickel chloride or nickel sulfate, then it will be what color?
I haven't seen such.
Okay.
color.
Anybody knows? What any of the panels knows? Okay, it will be green color. Nickel is green color. I mean
Oh,
nickel salt. Okay, nickel sulfate or nickel nitrate. Okay, it will, or nickel carbonate. It's bright green. Okay, but then if
yeah, we
nickel
can.
solid nickel, it will be just silverish color. All right. Okay.
Yeah, we can
So
use also another catalyst in this reaction. We can use actually aluminum oxide.
yes.
And the pressure is 2 to 3 atm pressure. The condition is not that easy to get high pressure, high temperature to get this reaction.
You're referring to which reaction?
Sabatier reaction.
Oh, Sabatier reaction. Okay, okay. Okay. So okay, Mufre, I'm going to ask you, because just now I just asked a little bit detail on Sabatier reaction, but I'm now asking you about the first method of getting methane from is it from
biogas process.
from biogas. Okay.
Yeah.
Can you actually produce biogas at your house?
Of course, it's possible. Actually, I'm thinking about doing it at my home country, at my home, actually, from the garbage and the organic matters that we are producing after cooking, after eating. All the organic materials that we can use, we can put it in a container or like a device that anybody can make. So we can put them in a sealed container, and by time and the bacteria will decompose the materials, and we will reach a equilibrium phase, and it will be more acidic, and everything will decompose till we reach the level of a methane and a water.
But if you do that, what will be the composition of product? I mean methane product, because there will be definitely gases will be released, but then is it 100% methane, or methane is one of the component inside the biogas?
Of course, it's only one product. We will have water, another acids, so many other byproducts.
Okay. Thank you for your response. Okay, I'm going to move to Dr. Vilmal Raj.
Hi, Doctor. Vimal.
Hi.
Yeah.
Yeah, you really look very, very professional, like a real doctor. Okay.
Thank you, Doctor.
Okay, welcome. Okay, is there any possibility of getting methane from bacteria?
Yeah, actually, based on the biomass reaction, actually, it is bacteria that produce the methane gas.
Okay, how?
Actually, the facultative microbes, which is the bacteria, converts the simple monomer into the mixed acid products, hydrogen and carbon dioxide. So, in the condition of slightly low pH, 5 to 6 pH, which is slightly lower than neutral, causes the toxic environment to metagenic. The 5 to 6 pH is the best pH for the bacteria to produce methane gas. And the metagenic bacteria, which is the methane producing bacteria, degrades the volatile acids present in the waste product to create more neutral pH. So in this condition, the bacteria will use the waste to produce methane gas, carbon dioxide, oxygen, and others.
Okay. So
is it clear?
Yeah, it's clear, but I hope your explanation is also mentioned in the one-page note. Is it mentioned there?
Yeah, it is mentioned.
All right, perfect.
All right. Okay.
Okay, here's another question to you as well. To you again, okay?
Okay.
can the biogas be produced without the bacteria?
Without the bacteria,
Without
I
the
think,
microbes.
without the microbe,
Hmm.
I think it is possible, but then we have to use heat to heat up the like the rice husk, the paddy field. So we need to heat up it to produce methane gas.
Because from what I believe, from my prior knowledge, it can happen without the microbes, but that process will be slower.
Yeah, it is slower.
Okay, so if we
Actually,
want to,
okay, the best condition is the microbe together with generated heat. So it
oh,
can
okay,
produce the highest rate of the methane.
all right, okay,
Okay.
okay. So do you produce do you produce or do you have the facility to produce biogas behind your house?
Behind my house, no.
Not yet.
Not yet, yeah, not yet.
Okay, but I
Maybe in
believe just
future we
now,
can, yeah.
just now Engineer Mufre said he will be doing that, right? Okay.
Yeah, why not? It's possible. We can.
Yeah, it can be done, right?
We can
Okay.
get back in the kitchen.
Okay. Back to IR Sarmila. Okay. Let's say you can get the biogas, sorry, you can get methane that is produced from biogas behind your house. Okay, Engineer Sarmila. Okay. So will you actually use the the methane gas for cooking? Do you think it is safe, it is hygiene, it is okay, acceptable? So what's your opinion?
I think it can be used, Doctor.
So you have no doubt of using it for your own purpose.
I think it can be used, but we have to follow all the safety precautions.
Okay. So I think it is no problem because it is just methane and then it will be burned. Right. Okay, thank you very much, Engineer Samila. Okay, I'm going to move to the very, very cheerful and happy Muhammad Haikal, Dr. Muhammad Haikal. So I think he is being interrupted by somebody there. Okay. Um, okay, here's the question.
Yes.
Why Malaysia, why our country is not yet having gas piping to each and every house, but we still use gas cylinder? You understand my question?
Yes. I think in order for the in order for the Malaysian government to do the gas piping to all houses will cost a tremendous amount of money in order to do that. So and since right now we are relying on the gas cylinder, so and technically I think the by depending on the gas cylinder it is quite reliable for all the person at the house to use the gas. So I think that's why Malaysia does not need the gas piping to all houses.
Okay.
Yeah.
Thank you. So because last time when I was studying in UK, we used to have that gas piping. We don't use any gas cylinder. But then when we come back to Malaysia, then we have to use that. How about Mufre? What about your place, your country?
Yeah, man. We barely are producing like the gas that we need. We just recently started depending on ourselves and producing that gas, so we are a lot like away from doing piping.
You are away from doing pipings.
Yeah, we just recently start depending on ourselves to get the gas.
Okay, so you are relying and using the cylinders.
Yeah, of course.
Okay. Okay, guys, thank you very much. I don't have any more questions for you guys, but I hope we can meet somewhere in future, okay, for other processing tonight talk show session. Okay, so let's just recap here. So we have methane, and then what we did today, actually we studied about hydrogen cyanide, okay, carbon dioxide, carbon disulfide, synthesis gas, chlorinated methane, single cell protein that can actually be produced from methane. And then from synthesis gas that is produced from methane, we can produce further chemicals, namely hydrogen, etc., etc., until methanol. And then from from hydrogen, we can mix it with nitrogen to produce ammonia. And from ammonia, we can produce further more chemicals. Okay. And then believe it or not, from nitric acid, okay, we can produce more things as well. All right. From alkanol amines, we can produce more things as well. So this is not the end of the journey for these chemicals. So there are still more things that can be produced. And then we also have methanol that was produced from synthesis gas, and this methanol produces formaldehyde, acetic acid, and so on until Mtg, which is methanol to gasoline, and all of this can actually be produced from methanol. And believe it, from acetic acid as well, as we can produce other things. Okay, I'm presently doing a research now, Oh wait, I think Farah know about this. Okay, Farah, Dr. Farah, Dr. Farah ke? Okay, because we are. Pardon? Hello. Okay, some interruption. Okay, we are actually trying to convert acetic acid to light hydrocarbon, okay, to low hydrocarbon. So which means it's like a recycle loop. Okay, from hydrocarbon, naphtha, petroleum, which is hydrocarbon, produce methane, and then produce syngas. Syngas produce methanol, and then methanol produce acetic acid, and then acetic acid we can produce back hydrocarbon. It is possible. Okay, so I'm doing that research at the moment, and it's interesting to know that. Okay, I also have been doing this gasoline methanol to gasoline research as well. Okay, so I think that's all. Do you have any questions for me or for the others? Okay, or all the panels are already tired. Okay, if you are still there and you are ready to go, clap your hand. Okay, I think that's all for today. Okay, I really appreciate your time, okay, spent for this processing talk show. I'm happy that you have prepared a very fantastic presentation as well as one-page note. Okay, I'll include the other two teams one-page note inside the e-learning soon. Okay, and I hope you guys learn from each other in this session. Okay, so if there's nothing else, okay, thank you very much. Selamat berbuka puasa, okay, to the Muslim, okay, happy fasting, okay. So I hope you guys are not nervous just now. This is just nothing. This is just for fun, okay. So hopefully you guys are okay. So can I see who here is actually very nervous just now? Just what's the icon that I can use here? Okay, if you are very nervous, you put this smiley face, this one. Okay. So actually this is okay. I hope you have fun with the experience. Okay guys, thank you very much. See you next week. Okay? So bye-bye. Thank you very much.
Thank you, Doctor.
Thank you, Doctor.
Thank you.
Thank you, Doctor. Doctor,
Yes.
may I know when is the test one for test one?
Test one. When do you want the test one?
Follow the majority.
Follow the majority, or you need to discuss with Abang?
Next semester.
Okay, later I will decide, okay, when to give test one. I think maybe in week number 7 or 8 or 9. So now is week 6, right? So 7, 8 or 9. Okay, so I'll double check and confirm with you guys later. All right, thank you very much, guys. See you. Assalamualaikum.
Bye, sir.
Thank you, Doctor.